Okay, so here we have a volume of the solid where the base is the ellipse 9x squared plus 4y squared equals to 36. And the cross-sections perpendicular to the x-axis are isosceles right triangles with a hypotenuse in the base. So since they're isosceles triangles, that means that this side right here is going to equal to this side right here. Okay, so this is the equation of the ellipse, and so we'll use that. So because we're integrating, because it's perpendicular to the x-axis, then we're going to be integrating in this direction. So we're going to integrate with respect to x. And so that's important to know because when we're formulating our cross-sections, we need to have them with respect to x. Okay, so let me draw this triangle right over here so that we can kind of figure out what to do. So let's say this triangle, this is one of the cross-sections. So they don't look the same, but this side right here is supposed to be the same. This side, let's call this side A, and this side A. So these two sides are supposed to be the same. Okay, and then let's call this side C because it's the hypotenuse. Okay, so to find the area of the cross section is going to be equal to the base times the height. So if you look at this guy, the base is A. So this is a right triangle. So the base is A and the height is A. So the height is 1/2 A squared. Okay, so that's good. Now, then what we need to do, though, is put it in terms of x. Okay, so, all right. Well, so then what we need to do, since we know the equation of this guy right here, we need to find what the length of this side is right here. So let's do first, okay, so let's write down, the Pythagorean Theorem tells us that a squared plus a squared equals c squared. So 2a squared equals c squared. So that means that a is going to equal to c over the square root of 2. So now let's figure out what c is equal to. So notice that the distance from here to here, that's going to be y. And so then let's solve for y here. So since I know that 9x squared plus 4y squared equals to 36, so that means that y is equal to 36 minus 9x squared over 4, and then the square root of all of that. Okay, so let me simplify this a little bit. If I take out the over 4, so this is going to be 1/2 the square root. So square root of 4 is 2. And then here I can factor out a 9. This is just a little algebra. And then 4 minus x squared. So I can take out the square root of 9 is 3. So then y is equal to 3 halves square root of 4 minus x squared. Okay, and so then since I know that that's just from here to here, so the whole length from here to here, all of C is twice what this is. So that means that C is equal to twice this, which is just 3 times the square root of 4 minus x squared. Okay, so then plugging that into this guy, I know what A is, and so then what that means is the area of the cross section is going to equal to 1/2 A squared. So 1/2 A, which is C over root 2, so 3 square root of 4 minus x squared over root 2 squared. Which, if I simplify, so here 3 squared is 9, and then square root of 4 minus x squared is just 4 minus x squared, and then over root 2 squared is just 2 times 2 is 4. So this is the area of the cross section. And so then what this means is that the volume is equal to the integral from this point right here to the other side of the ellipse. Now these are the x values, and that's going to be equal to -2 to 2. So from -2 to 2. And you can find that by just plugging 0 in for y, and you would get the x values. So from -2 to 2, we're going to integrate 9/4 times 4 minus x squared dx. And so when I do that, I'm going to get, when all is said and done, that this whole thing is equal to 24. So we'll get the antiderivative, top minus bottom. I ran out of room, but you guys can finish it off from there.